Today we are going to discuss about center of gravity. In center of gravity, we are going to discuss centroid, axis of reference, center of gravity of a composite figure, and numericals on center of gravity. So let us discuss about your centroid. So basic definition of centroid is it is the geometrical center of an object. So for a geometrical center, if we want to find out a geometrical center of an object, then we called it as a centroid. Okay. So let us discuss about this figure. This is a rectangle. In a rectangle, its geometrical center is here. Okay. So how we find out this? If we draw one line from this side, if we draw one line here, and if we draw another line here, then the center point is known as the geometrical center of your rectangle. Okay, so this point is the centroidal point or centroid of for this rectangle. So let us discuss about circle. For circle, its centroidal point is this point. Okay, is the O point is the centroidal point of for circle. In case of a triangular object or in case of a triangle, the centroidal point is here. Okay. So if we are going to find out the centroidal point for different figure, then we can easily find out this by figure or by common sense. We can easily find out this centroidal point. Next, we are going to discuss about axis of reference. What is axis of reference? These are the reference axis about which the location of center of gravity is calculated. So the centroidal point from which we calculate the centroidal point is known as your axis of reference. Okay. For plane figure, the lowest line we consider as the axis of reference. Let us discuss. So this is a suppose this is a rectangle. In this rectangle, we consider this x-axis and this y-axis as your axis of reference. Okay. So we have previously discussed that for a rectangle, its centroidal point is here. For a rectangle, its centroidal point is here. So this centroidal point, the distance between the x-axis to the centroidal point is known as your y bar. From x-axis to the centroidal point is known as your y bar, and from y-axis to the centroidal point is known as your x bar. Okay. Next, what is center of gravity? It is the theoretical point in the body where the total weight of an object or the total weight of an body is assumed to be concentrated. Or it is a theoretical point, not a practical point. It is a theoretical point on which the total weight of the body is assumed to be concentrated. So how to find the center of gravity for a composite figure? To find out the center of gravity of a composite figure, we have to follow these steps. In step number 1, we define the axis of reference. First, we have to define the axis of reference to find out the center of gravity of any composite figure or any plane figure. Step 2, find out the center of gravity of an individual area from the reference axis. And in step number 3, determine the center of gravity of whole composite figure from the reference axis. So to find out the center of gravity of a composite figure, we have to follow these 3 steps. So let us discuss a problem on which we are going to find out the center of gravity of a I section, where we follow this step to find out the center of gravity for the I section. Okay, let us discuss the problem. So the problem is, in an I section, the following dimension is given. Your bottom flange, the dimension is 300 into 100, and the top flange is dimension is 100 into 150 into 50, and wave is 300 into 50. So first of all, what is bottom flange and what is wave? So this one is your bottom flange, this is your bottom flange, and this is your top flange, and this is bottom flange, this one is top flange, and this is your wave. Okay, so in this figure your bottom flange is here and the top flange is here and the wave is here. So he is giving the dimension of bottom flange, top flange and wave. We have to find out the center of gravity of the I section. So let us follow the steps and find out the center of gravity of this I section. So in step number 1 we have to determine, or we have to define the reference axis. Here the reference axis are this one. This is your x axis or this is your y axis. Okay. So we have to find out the center of gravity for this I section, and first of all we have to define the section. This is your rectangle number 1, this is your rectangle number 2, and this is your rectangle number 3. So we have to define this composite figure into 3 simple figure, that is your first rectangle, second rectangle and third rectangle. Let us discuss how to find out the center of gravity for this I section. Okay. First of all, we have to find out the center of we have to find out the area of first figure. So area of first rectangle. Area of first rectangle. Again, I will mention the reference axis. Yeah. Okay. So first figure, your first rectangle is here, second rectangle is this one, and third rectangle is this one. So first rectangle, the area of the first rectangle is 150 into 50. 150 into 50, that is your 7500 mm square. And next we have to find out the x1 and y1 for the first rectangle, that is your x bar or y bar. Okay, so for first rectangle your x1 is distance from the y axis. So the center point of the first rectangle from the y axis is known as your x1. So what is the value of x1? X1 is your 150 mm. Next y1. Y1 is the distance of the center of gravity of first rectangle from the x axis. So from the x axis, the center of gravity of first rectangle is this distance is your 100 mm, and this distance from here, this distance is 300 mm. So 100 plus 300 to 400 mm plus 50, the half of the 50 mm, that is your 25. So y1 is your first 425. Like this, we have to find out the center of gravity of second rectangle and center of gravity of third rectangle. So when you go for the second rectangle, likewise you have to find first the area of second rectangle. Area of second rectangle. Here is your length is your 300 mm and width is your 50 mm. So area is 300 into 50 equal to 15 000 mm square. Okay, this is the area for the second rectangle. Again, we have to find out the x2 and y2. So for when we are going to find out the x2, it is the distance from the y-axis. The center of gravity of the second rectangle from y-axis is known as your x2. So what is the distance? This distance is half of the 300 mm, that is your 150 mm. So then x2 is equal to 150 mm and y2 is equal to y2 is the distance from the x-axis. The center of gravity of the second rectangle from x-axis is known as your y2. So what is y2? Now y2 is 100 mm plus 100 plus 300 mm divided by 2. So your 250 mm. This is your y2. Okay. So let us go to the next slide. Okay, again I will draw the reference axis here. Okay, so we have already find out the area of first rectangle and the area of second rectangle and the center of gravity for the first rectangle, that is your x1, and center of gravity of the second rectangle, center of gravity of the first rectangle from y-axis, that is your x1, and center of gravity of the first rectangle from x-axis, that is your y1. So I will mention here. So area equal to here 7500 mm square, x1 equal to 150 mm, y1 equal to 425 mm. We have already defined how to find out the x1 and y1. Okay. Then for second rectangle, a2 is equal to, second rectangle this one, a2 is equal to your 300 mm into 50 mm. So 15,000 mm square, and x2 is equal to 150 mm, y2 is equal to 250 mm. Finally, we have to find the area of the third rectangle and your x3 and y3. Okay. So area of the third rectangle, which is a3, is equal to your 100 mm into 300 mm. So for rectangle, this is length into breadth. We already know that. So your area is your 100 mm into 300 mm. That is your 30,000 mm square. Okay. Then we have to find out the x3 and y3. So x3 is your distance from y-axis. The center of gravity of the third rectangle from y-axis is your known as your x3. So x3 is equal to 150 mm and y3 is equal to, y3 is the center of gravity of the third rectangle, the distance of center of gravity of third rectangle from x-axis. So this is your 50 mm, because this is total length is 100 mm. So center of gravity lies on the half of the breadth. So this is your 100 divided by 2. This is your 50 mm. Okay. So y3 is 50 mm. So we have already find out the area of first rectangle, area of second rectangle, and area of third rectangle, center of gravity of the first rectangle, center of gravity for the second rectangle, and center of gravity of the third rectangle. So our question is asked, so find out the center of gravity for total I section. or for this composite figure. So here we are using some formula, that is your x bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So by putting this value, what is your a1? Now a1 is 7500 mm square, x1 is your 150 mm, y1 is your 425 mm, a2 is your 15000 mm square, x2 is 150 mm, and y2 is 250 mm. A3 is 30,000 mm square, x3 is 150 mm, y3 is 50 mm. So by putting this value here, we can find out the x bar is equal to your 150 mm. Okay. So what do you mean by x bar? The x bar is the distance of the centroidal axis, or the x bar is the centroidal point of total I section from the y axis. So suppose your centroidal point of this I section is here. So this point, the distance of this point from this axis is known as your x bar. This is your x bar. This is the centroidal point of total I section. So this the centroidal point which is here. This distance from y axis is known as your x bar. Okay. Likewise, we can also find out the y bar. So how to find out the y bar? Same. Okay. So let us find out the y bar. So y bar is equal to, same formula we have to write down here, a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Okay, this is the formula to find out the centroidal point or the centroidal point of the I section from x axis. I have to write down there here. Here this is your y axis. So suppose this point we are considering as this is the centroidal point for the total I section, then this distance from y axis is your 150 mm, and this distance we have to find out, which is your, this is your x bar, and this distance is known as your y bar. So what is the distance from x axis from this point? Now, by putting this value, we can determine the distance is your 160.7 mm. This is the distance of centroidal point of this total I section from x axis. So this is your y bar, and your x bar is 150 mm and y bar is 160.7 mm. So here we can mention also 150, 160.7. Okay, so this is the center of gravity for the total I section. Okay, likewise we can also find out the center of gravity for the T section, for the C section, and for the L section. Okay, in next video we are going to find out the center of gravity of the T section or for the L section. Okay, thank you everyone for watching.